When you picture a volcano erupting, you're probably thinking of fire, intense heat, and all that molten rock, right? But get this. What if I told you some of the biggest volcanic eruptions in history actually made our entire planet cooler? Yeah, it sounds completely backward, but it's a super fascinating scientific mystery that's hidden right in the data. And today, we're going to solve it.
So let's just start with that big question. What kind of event could possibly have enough power to lower the average temperature of the entire globe? I mean, that's a huge deal, but as we're about to see, it's happened before.
Okay, take a look at this graph right here. This shows us the global temperature changes back in the early 90s. You can see the temperature's kind of bouncing around, mostly a little bit above average. But then, bam, right in the middle of 1991, something happens. The temperature just plunges. So what was the culprit? An eruption, specifically Mount Pinatubo in the Philippines. This is our mystery.
Now, to really get to the bottom of this, we're going to use a simple but really powerful scientific framework. It's called CER, which stands for Claim, Evidence, and Reasoning. This is basically how scientists build an argument, and it's the perfect tool for our investigation.
First up is the claim. A claim is just a simple, straightforward statement that we want to investigate. So in our case, the claim is pretty simple. The eruption of Mount Pinatubo directly caused a change in the global climate.
Next up, we need evidence. Now, this isn't about opinions or feelings. This is the hard data, the stuff we can see and measure. These are the facts that you really can't argue with.
And finally, there's the reasoning. This is maybe the most important part. It's the why. It's a scientific principle that explains how the evidence actually supports the claim. It's the glue that holds the whole argument together.
All right, we've got our toolkit. Let's put it to work and apply it directly to the case of Mount Pinatubo and that mysterious temperature drop back in 1991.
So here's our claim again, nice and clear. The 1991 eruption of Mount Pinatubo affected the global climate. Simple enough, but now we've got to find the evidence to back it up.
And for that, we go right back to our star witness, this temperature graph. The eruption is clearly marked right there, and you can literally trace with your finger the immediate impact it had. Let's really break down what these numbers are telling us.
So let's turn that visual into some cold, hard facts. In 1990, just before the eruption, you can see temperatures were consistently above average, somewhere between positive 0.1 and 0.4 degrees Celsius. But then look what happens in the year and a half after the eruption. They drop big time, down to between negative 0.1 and negative 0.4. That's a total swing of about half a degree Celsius across the entire planet. That right there is our undeniable evidence.
So here's the reasoning that connects those dots. You might think it's the ash from the volcano, but it's actually something else. The volcano blasted millions of tons of sulfur dioxide gas way up into the stratosphere. This gas creates this kind of haze, tiny little droplets that act like a giant planetary sunshade. They literally reflect sunlight back into space before it can reach us, and that cools the planet down below. That scientific principle is the crucial reasoning that proves our claim.
Okay, now any good scientist would ask this next question. Was Pinatubo just a fluke? A one-off coincidence? Or is this part of some bigger, repeating pattern? To figure that out, we have to zoom out and look at a lot more data over a much longer time. And this graph, wow, it spans over 100 years, and it gives us our answer. Look closely at the major eruptions marked here. You've got Krakatau, Agung, El Chichon. After every single one, what do you see? A distinct, sharp dip in global temperature. Pinatubo wasn't an anomaly at all. It was just the latest example of a very clear and powerful pattern.
And just laying them out on a timeline like this makes the pattern impossible to miss. From Krakatoa way back in 1883, all the way to Pinatubo in 1991. With several others in between, history keeps telling us the same story. A major volcano erupts, and for a short time, the entire planet cools down. The evidence is just overwhelming.
So where are all these powerful volcanoes? Well, this map shows us recent eruptions and earthquakes. You can't help but notice that heavy concentration of black triangles. Those are the active volcanoes. And see how they snake all the way around the Pacific Ocean. This is the famous Ring of Fire, a super active hotbed for this kind of geological activity. And it's where a lot of these planet-altering eruptions happen. So, we've used our scientific toolkit, we've investigated the mystery, and we've uncovered this incredible pattern in our planet's climate history. But what's the big takeaway here? Why does this connection between volcanoes and the climate even matter? Well, the big takeaway is this. Massive volcanic eruptions are one of nature's most powerful climate forces. Seriously, they can act like a temporary thermostat for the whole planet, basically dialing down the global temperature for a year or two before things go back to normal.
And that really leaves us with a final and pretty important question to think about. If just one single natural event can cause such a rapid and measurable change to our entire climate, what does that tell us about how sensitive our planet really is? It's a powerful reminder of the incredible, dynamic forces that are constantly shaping the world we live on.